So, visualizing with Matplot. Matplot is a function which is used to create graphs. Matplot in R is the most concise way to superimpose the data series. Matplot plots the columns of a matrix individually as a function of x. So basically we can say that as a function of x we can plot the columns. Syntax for matplot in R is given below. It is like matplot, within the parenthesis we pass the variables x, comma cbind. With the help of cbind function we pass y1 and y2. Y1 and Y2 are vectors or columns of a matrix or data frames. So we can understand it that there is a matrix and in the matrix there are two columns Y1 and Y2 which are vectors. And now we are plotting the columns of matrix individually as a function of x. Now this is a little code where you can see that we have used our matplot function. X is equal to 1 to 10, which is the series of 1 to 10, and y is equal to x square, and z is equal to x square minus 2x. You can see that the formula is written where x to the power of 2 is means x into x, and z is x into x minus 2 into x. And matplot is a function where within the function we are passing x, which is our value from 1 to 10, cbind, and we are passing y and z, and then pch where we are giving 16 say 1, and xlab is equal to x and ylab is equal to x square. You will ask what is xlab? So xlab is basically the label on the x-axis and ylab is the label on the y-axis. Now just have a look of the graph and understand the explanation over here. So x is a vector from 1 to 10. We can see x is a vector from 1 to 10. Y and z are function of x. The command matplot x cbind y comma z will produce graph in which has points of the two data series. So we have two data series y and z. So one is printed in black where you can see column is equal to 1 and the other is printed in red which is column equals to 2. So the two series are printed in two different colors, and xlab and ylab are the label on x and the label on y are x-axis as well labels as well as y-axis labels respectively. You can note that matplot automatically sets ylim to include both the data series. Subsetting and visualizing subsets. So now what are subsets? Subsetting allows the user to access elements from an object. It takes out a portion from the object based on the condition provided. So basically, when I have to find out a particular subset or I have to take a particular subset from a data, I have to give a condition. That is a criteria. So if I give a criteria, the values which satisfy the criteria are taken out and the values which are not satisfying are suppressed. And that is how I take a subset from a data set. So basically, there are 4 ways of subsetting in R programming. Each of the method depends on the usability of the user and the type of the object. For example, if there is a data frame with many columns such as states, country, population, and suppose the user wants to extract states from it, only the states. So if it is a data frame and I want to extract only the states from it, then subsetting is used to do this operation. Subsetting in R using square bracket operator. So using the square bracket operator, elements of vectors and observations from data frames can be accessed. So basically, we can extract elements of vectors and observations from the data frames. To neglect some indexes, I can write a minus sign or I can say a hyphen is used to access all other indexes of vectors of data frame. Let's have a look on the example. Cat first 5 values of vector. So now I only want to have the first 5 values of a vector. So what will I do? X 1 colon 5. Now here x is my vector, and within the square brackets I have passed the range of the subset, which is 1 colon 5. So this is as good as indexing. I have not used the comma to extract the exact value of the matrix, but I am trying to find out a subset of a huge vector x. Now, after taking the subset, you can see over here in this example that x is a vector 1 to 15, and I have to print the original vector x. So how I will print? I write cat original vector x. So cat original vector x means it will print x as it is on the screen. Then I have to subsetting vector where I will print first 5 values of the vector. So how will I print? I will print x 1 colon 5. So what I'm printing 1 colon 5, which means the first value, and from second, third, fourth and fifth value. So 5 values are printed on the screen. Next we are printing without values present at index 1, 2 and 3. So here what I'm doing? I'm passing the index 1, 2 and 3, but I don't want the values to be printed on the screen. So the value at index 1, value at index 2 and the value at index 3 is not needed in my subset. So basically I am doing suppression of the values of 1, 2 and 3, and from 1 to 15 removing 1, 2 and 3 third location, rest all values I want to print on the screen. So you can see over here that in the last cat line we have written without values present at index 1, 2, 3, we write x square brackets, and within the square brackets we write minus c, and within the brackets 1, 2, 3, which means the 3 indexes. So now let's have a look of the output. You can see over here in this example, the original vector is from 1 to 15. You can see 1, 2, 3, 4, 5 till 15. The first 5 values of the vector are 1, 2, 3, 4, 5, which are printed with the help of the colon operator. And without values present at 1, 2 and 3, we can see the values printed over here are 4, 5, 6, 7, 8, 9 till 15. So that is how we are printing subsets of a particular vector. The original vector is quite a long vector from 1 to 15, but when we are printing a subset of it, we have used the range operator where I want to pull values from a particular lower range to a upper range, and sometimes I want to suppress certain values. So in that case, I use a minus c function inside the vector, and I write minus c, and within parentheses I give the indexes. Next is creating a vector in R. We all know that when there is data, data can repeat in certain columns, but sometimes such kind of data is not needed. For example, if the data is a city, it can have multiple times Mumbai, 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 or Delhi, Delhi, Delhi. So I want to know how many unique cities are there in this data set. So in such kind of cases where I want to know how many unique values are present in this data set, I have to apply the factor. Factor in R programming language are data structures that are implemented to categorize the data or represent categorical data and store it on multiple levels. So basically, what we do, we divide the data into categories and start storing that on multiple levels. They can be stored as integers with a corresponding label to every unique integer. So we can say we can store that as integers. Though factors may look similar to character vectors, they are integers and care must be taken while using them as strings. The factors accept only a restricted number of distinct values. So basically the idea is that a factor will have a list of distinct values in a particular column. So if there is a column where we are having, say, country, city, zones and quarters, such kind of data is there. In that case, or maybe codes, in that case we want to know how many distinct values are there, and then we definitely apply factor function on the vector. The factor is our data, and we apply the factor function on the data to find out how many distinct values are present in that vector. Let's start understanding with the help of an example. A data field such as gender may contain values only from female, male, or transgender. So you can say that suppose I have a variable gender where I am storing information of, let's say, 1 lakh employees, but there are only three values which are stored in the field gender, and they are female, male, or transgender. So after a factor is created, it only consists of levels that are by default sorted alphabetically. Let's talk about attributes of factors in our language. So the first one is x. X, it is the vector that needs to be converted into a factor. So the first is the x, which is basically a vector that you have to convert into a factor. So x is basically a list of, let's say, gender that we have to convert into a factor. For example, a list of gender can be male, male, female, female, male, male, and so on. So we have to just find out what are the main factors in that x. Next is levels. So level is a set of distinct values which are given to the input vector x. So these are the set of distinct values which are the levels that are predefined, and we give this as input to the vector x. Labels. It is a character vector corresponding to the number of levels. So basically it is a character vector which is corresponding to the how many labels are there. Exclude. This will mention all the values you want to exclude. Ordered. This logical attribute decides whether the levels are ordered or not. Nmax. It will decide the upper limit of the maximum number of levels. So these are the attributes of factors in our language. Let's take one example and understand the concept in detail. The command used to create or modify a factor in our language is basically called as factor. The way we had matrix to create a matrix, we have a factor to create a factor. So it is a factor function with a vector as an input. The two steps of creating a factor are, first is create a vector where we are just creating a factor gender with levels female, male, and transgender. So what we have done over here, that the first step is creating a vector where vector is created and stored in x. Vector is having the values female, male, male, and female, and then converting the vector x into a factor named gender. So what we are doing over here, we are assigning factor function, passing the x vector as a parameter and storing that in the gender variable. And then finally we are printing the gender. So I repeat, the two steps over here are, at first I have created a vector, and then finally the vector x which I created is passed as a variable in the factor function, and the factors are stored in the gender. So you can see over here that there are two factors, one is male and the other one is female. So you can see over here that the output of the vector is female, male, male, and female, but the output of gender is female and male, which means it has taken distinct values and the value which is repeating is taken only once. Labels can also be predefined by the programmer. Creating a factor with labels defined by programmer. How we can do it? We have taken a gender where we are passing the C function, the function which is creating a vector, female, male, male, and female, and passing that into the factor. We are passing that into the factor, and there after a comma, we have defined the levels equal to female, transgender, and male. So their labels are predefined by the programmer. You can see over here that we have defined the levels as female, transgender, and male. And then we are printing the gender as output. So as you can see in the output that our factor, our vector is female, male, male, and female, which we have created, but the levels are female, transgender, and male. So that is how we are creating a particular level in a vector.